Okay, so to start this, I want to start with question number 3 before I do question number 1. So let's go to question number 3, you guys. Everybody see that? So if I take a look at question 3, one of the first things that hopefully you recognize is you don't cancel the x squareds. Don't.
You can't.
Don't cancel the x's. What we need to do is factor.
Mr. James, you didn't say the page a million times, but we're all road.
Page 183. So what I'm going to do is factor. And when I factor, I'm hoping to find something on the top that's identical to something on the bottom, and then I can cancel. So if I factor this, I know if I factor the multiples of 4, 4 and 1, if I do an x minus 1 and an x minus 4, it'll work. And on the bottom, or the denominator, if I factor the denominator, multiples of 1 are 1 and 1, but I need a negative 1 and a negative 1. Now, because I'm multiplying this times this times this, I can cancel the x minus 1s with the x minus 1s. But it's parentheses x minus 1 over parentheses x minus 1, so I cancel both terms. And what I'm left with as an answer is x minus 4 over x minus 1. That's my answer. So if you can factor, you're going to find this stuff's not that bad. Okay, let's shift over to number 4. Okay, so if I look at number 4, and again on the numerator, the top, I can common factor out an x squared, right? If I take out my x squared, out of the first term I'd have an x, and out of the second term I'd have a plus 3. In the denominator, I'm going to do multiples of 24, minus 8, plus 3, right? So I'm going to go ahead and factor that to an x minus 8 and an x plus 3. Now, my x plus 3 can cancel with my x plus 3. And what's left over is the x squared over x minus 8. And Cooper's paying attention, isn't he? Okay. He's going to put that phone away. So then, let's go back to question number 1. So let's go back to question number 1. So question number 1, you're only going to factor the top, the numerator, right? So I'm going to take out a common 2x squared, and what I'd have left is a x minus 4. In the denominator, I cannot factor that, but that's okay, because if I line these two up, I can cancel, right? Now I can cancel an x squared for an x squared. I can reduce this to 1/3. So my answer would be 1 times x minus 4 over 3. There's my 1/3. You do not need this 1 here, but it shows the 1/3. You do not need the 1, but it helps us see the reduced to 6s, okay? Cody?
So if it was a 2, would you distribute it?
Here?
Yeah.
You could, absolutely. I'm going to tell you not to, because later on it's going to be beneficial if you don't, okay? But yes, you could, okay? Okay, let's look at number 2. Same thing. On the top, or the numerator, we can factor out a x and a y squared. That's my common term. Okay, and what's left out? What's left is going to be a 5y minus a 2x. The denominator we can't factor at all, but I can cancel. I can cancel an x for an x, a y squared for a y squared. And so my answer would just be the 5y minus 2x over my y. How am I doing?
So good.
Okay. I'll check that out later. Okay. Huh? Okay.
The denominator.
Oh, I should have an x. Thank you. Should be just an x. Thank you. I got a little distracted, didn't I, Cooper?
Can you slide it for us?
Yeah. There you go. You're welcome. Okay, now if we jump down, let's go straight to let's go to number 8 first, okay? I'm jumping around, but you'll see why. Let's go to 8 first, okay? So if I go to 8, we're just going to factor. Factor, 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 and then we're going to cancel, 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 okay? So we're going to factor.
And then what?
So then we'll cancel. Thanks, Ben. How about an x minus 3, x plus 1? Multiples of negative 3, that up to a negative 2. In the denominator, x plus 1, x minus 1, right? The second fraction, I'm going to factor the numerator, x minus 9,
What are we doing?
x plus 7. We're going to cancel, Ben. It's going to be a nice long weekend, isn't it? And then, Ben, I'm going to factor, okay?
Okay.
We're going to go x plus 7, x minus 3. Ben, what are we going to do next?
What are we gonna do?
Can we cancel something,
Oh,
Ben?
let's do it.
Let's do it. What cancels?
Do you have to cross the cancel thing?
Anything on the top. Anything on the top with anything on the bottom, because it's all multiplied all the way across. That makes sense? So yeah, boom, boom. What else can we cancel? X plus 7. Boom, boom. What else can we cancel? There you go. What's left?
X minus 9 and X minus
And that's my answer. X minus 9 over x minus 1. So this stuff's not bad. It's actually kind of fun.
Wait, Mr.
I think
Reed,
it's kind of
what were
fun,
the
but you have to
steps
be able to
we took
factor,
get
don't
there?
you?
Math is
Huh?
like art.
What were the steps we took to get
Different.
there?
It's so different than our.
Factor and cancel, Ben. Factor and cancel. Okay, so then if we look at number 5, so in number 5, there's no factoring. It's just cancel, cancel, cancel. In this case, we could cancel anything on the top and anything on the bottom. So I can cancel an x for an x, right?
Let's do Y's too.
Okay, let's cancel out. In fact, there's 2 y's, aren't there, Ben? There's a y, y. So these 2 could cancel out those 2. And I'd just be left with a 3 over a 2x, right? Okay, nice. Now let's jump down to number 9. Okay, you guys are good on 9? Ben, let's factor, okay? So I'm going to factor that into a x times an x minus 2. I'm going to common factor that. This one's a perfect cube. We're going to actually use the top formula there.
serious?
Yep. And I'm going to let, this is the same thing as a 2 cubed. Okay, right? It's 2 cubed. So we're going to have a x plus 2 times an x squared minus 2x plus 4. Okay, there's my x is my a, 2 is my b, and I'm just plugging it into the top equation, right? Okay, x plus 7, I like that. You know why I like that? It's already factored. Down here, let's take out an x, and I'll have an x squared minus 4, but that can be factored again, couldn't it?
I bet you negative 2 and 2.
Ben, you are so smart. So now, cancel. Well, anything on the top with anything on the bottom, right? So this x is gone, right? This x minus 2 is gone. This x plus 2 is gone. And what am I left with? The x squared minus 2x plus 4. So thumbs up so far? Now, when we get to number,
What happened to
What
the
happened to
X
X plus 7?
did I forget it?
Mr.
Oh.
Davies.
It is Friday, okay? X plus 7. There, how's that?
Mr. Davies, you said it yourself. We just gotta factor and cancel.
Okay, let's do it. So, let's go to, but I'm going to change the rules, Ben. It is under the whole thing. Yeah. Okay, now, Ben, I'm going to change it up because when I divide, what do I do when I divide? I flip it.
Flip.
So we're going to rewrite this one. So we're going to go and rewrite this as an x plus y over a 7xy times, right? We're going to flip it, times y over 4x. And then we're going to factor if we can, but we can't. And then cancel, right? So this y cancels this y, right?
It does.
I think that's all you can do.
No, there's 7s, Mr. Davies. Oh, never mind. There's
I think that's all we can do. So I would have a x plus y over 28x squared. Oh, that's a lot sloppy. Okay. All right, let's jump all the way to 10. I'm getting there. Let's jump all the way to 10, and 10 will be the last one I have to do, okay? So 10. So we divide, we flip it. Which one do we flip, Ben? Ben, which one do we flip? First or second fraction?
Second.
Always the second one, right? So let's do that. So let's rewrite x squared plus 2x minus 15 over x squared minus 3x minus 40 times, let's flip it, x squared plus x minus 72 over x squared plus 8x minus 9. Okay, now what? Ben, what are we going to do next? So I flipped it,
Oh,
right?
I wasn't looking at mine, it says divide, I thought it said plus.
Yeah, okay. So what are we going to do?
Factor.
Factor. So let's see. If we factor, we're going to get on the first fraction in the numerator, x plus 5, x minus 3, right? First fraction denominator, x minus 8, x plus 5, right? Second fraction numerator, x plus 9, x minus 8. Second fraction denominator, x plus 9, x minus 1, okay? Cancel, 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 right? So let's cancel. What are we going to cancel?
All of it.
Seriously?
No.
No.
Match, Mr. Dave.
That with that.
Yeah.
What would happen if they all? What would happen
Let's
if everything
do X
canceled?
plus 5.
It's easy, low.
X minus 8, x plus 1.
So what's left over?
X minus 3, x minus 1.
Okay.
If they all cancel, you'd be left with nothing.
No. Good question. We talked about this in third period. Bella, do you remember? If everything cancels, you remember the answer?
One?
Yes.
Oh, yeah, because it's.
It's something over itself. It's something divided by itself. Does that make sense? So like 10 divided by 10, 1. 5 divided by 5, 1. X divided by X, 1. X plus 3 over X plus 3, 1. Something divided by itself is always 1. So if everything cancels, it's going to be
So
1.
where's the one go?
It's just, what do you mean, where's the 1 go?
So if you're dividing stuff by itself all the time, and then you just got all those ones.
Yeah, these are 1s. That's 1. That's 1. Well, actually, that's 1, right?
Yeah.
And then that's 1. And then that's 1. So you got all those 1s, right?
Yeah.
But 1 times 1 is 1. Times
Okay.
1 is 1. Times whatever we have left would be just
Yeah.
that. Good question. All right. We have lots of time. I have a homework sheet for you to do.